So now in this video we're going to look at the push button switch based NOT gate right here, not logic gate. We could also call it a digital signal inverter. Sometimes it's just called an inverter if you know you're talking about digital electronics. Problem with just saying inverter sometimes is that there's also inverters that take direct current in and they output alternating current, and so you got to be careful if you just say inverter. But in any case, here is the truth table. We'll look at how this works. So the input, we're going to use a switch here. So it's off in this position. You press down, it's on. When you turn it on, the LED down here, that'll be our output, will be off. And if you're not pressing the switch, so the switch is off like you see here, the LED will be on. So it's the different condition from the signal that we're getting, which in this case is moving a mechanical switch. You can see we'll have a current path there as long as the switch is open. The voltage across the diode will build up. You'll have the diode voltage across it and current will flow. It'll light up. If we close the switch, we'll effectively have ground on both sides of the LED. There will be 0 volts across there. No current can flow. It's going to need at least about 2-3 volts across it. Ground on both sides. You got 0. Any current getting through the resistor gets sucked right to ground. In fact, you'll have slightly more current while the button is pressed than when the LED is on. And the schematic symbol is right here. Normally you would use a digital component. There's integrated circuits with NOT gates in them, and they're much more energy efficient than what we see here. But we have the input there. So this is a buffer. It's telling you it's transferring that signal to the output, but this little dot here is an inversion. So when you see these dots, that means it's inverted. And so we'll have the opposite output of what we are inputting. So now this is a pretty simple circuit. We have a 220 ohm resistor coming to the top of the switch. Bottom of the switch is going directly to ground, and we're going to take the LED right there, and I spaced it so that there's a space in the middle. Long lead the anode to the resistor, short lead the cathode down. The LED is on because we already have power applied right there. And there you can see 12 milliamps of current going through there. If I press the switch, now we have, it actually wants to go above 20 milliamps right there. So let's raise that up. I set it to a limit. I think it'll still be below 25 milliamps. And there you go. It's just slightly above 20 milliamps going through that 220 ohm resistor now, and the switch, it's bypassing the LED. But in any case, you can see when the switch is off, LED is on, switch is on, LED is off. More interesting when it's digital, but this is a good demonstration for how the NOT gate works. So, hope you enjoyed. Make sure you check out one of the other videos I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. I put a link down in the description. That will help out a ton. I'll see you in the next video.